Okay, we didn't get to this graphing y equals 1 over x squared. And so we're going to look at that, and when we look at this kind of function, again, we have to think about where the range and domain are, what things can this be, what things can't it be. So in this problem, you've got x in the denominator, x squared in the denominator, so we know that the domain, just like 1 over x, when we did that one, x is all reals x, such that x is not 0. Because the only thing you can square to get 0 is 0, and so the only thing that we're not allowed to have for x is 0. So that knocks out the y-axis. We cannot touch the y-axis because that line, the y-axis, is the line x equals 0. That's where x is 0, so we cannot touch that. Then the range is going to be, we have to think about what happens when you square a number. When you square something, it always ends up being positive if we're in the real numbers. So y is always going to be positive. There's no way it can be anything but positive, and it also can't be 0 because it can never, there's nothing you could put in for x to get the value of 0 when you say 1 over x squared. So y is a real number that is strictly greater than 0. Can't be negative, can't be 0, so got to be positive because there's just no way to make it happen with 1 over x squared, which is a positive number. All right, so we see that we can't touch the y-axis and we can't touch the x-axis either because that's where y is 0. And we can't go anywhere into the realm of negative numbers with our y. We can't have a negative y, so we're never going to go below the x-axis in this graph. All right, so first of all, we think about maybe what some things on this graph are going to be. We know that if we are on the right side of the y-axis, and above the x-axis, over here in the first quadrant, we know that as x gets bigger and bigger, y gets tinier and tinier. Because if x gets bigger, it's making the denominator smaller, which makes the fraction bigger. So we'll just plug in a couple of points just to orient ourselves. If x is 1, y also would be 1, because 1 over 1 squared is 1. So we have this number here. When x is 2, y is 1 over 2 squared, which is 1/4. So already, even by the time we reach 2, we're getting really, really small. So we can see the bigger x gets, the smaller y is going to be, and it's going to get closer and closer to 0. So as we go to the right, we're getting closer and closer to that x-axis. All right, now as x becomes smaller and smaller, approaching 0 over here, but it can't touch 0, but as it gets tinier and tinier as a positive number, it's getting closer and closer to that y-axis, but y is shooting up, because if x is a tiny fraction like 1/1000th, then x squared is 1/1,000,000th, and if you take the reciprocal of that, you get 1,000,000. So if x is 1,000, y is already 1,000,000. So this is shooting up super fast as x gets tinier and tinier, closer and closer to 0, y is shooting up. Then we have to look at what other quadrants we can work in here between these asymptotes, which are the x and y axes. We're never going to go into the, let's go ahead and go to the second quadrant. All right, so the second quadrant is over here where x is negative and y is positive, and that's okay. X can be negative, and it will make y positive, because anything we put in here for x will give us a positive value when we do x squared. So if x is -1, y is going to be 1 over -1 squared, which is 1 over 1, which is 1. So now we have -1, 1 here for y, for our point that is on this graph. So we look at the situation here and we realize that y is always going to be positive. And what we're going to get is a mirror image of what happened in the first quadrant. Because now we're putting in the same values we're putting in negative values for x, but we're getting positive values for y, and they're acting just the same way. If the number that x is getting closer and closer to 0, getting to be some little fraction that is very tiny in magnitude, then y shoots up. It becomes this big positive number. So if x is negative 1,000, negative 1/1000th, I'm sorry, then 1 over x squared is going to be still positive 1,000,000. So as x gets tinier and tinier, y shoots up, getting bigger and bigger, but never touching that axis. I'm sorry, that looks like it does touch, but it doesn't. Okay, and then as x is getting more and more negative and it is having a bigger magnitude, when you square it, it becomes positive, so it becomes a much bigger number. So 1 over that number is getting tinier. So the reciprocal function, as the denominator gets bigger, the function itself gets smaller and smaller. Okay, so in this problem, you have a graph that looks a lot like 1 over x, except that the part of the graph that was over here in the third quadrant is now flipped up to the second quadrant because we can't have any negative values for y. There's no way to get them. Okay, so this graph only happens above the x-axis. So I hope that makes sense. If it doesn't, you need to shoot me an email and let me know if you need more help on this. So that's graphing y equals 1 over x squared.